Okay, ladies and gentlemen, we're going to do our video lesson today on rational versus irrational numbers, and we're going to try this webcam. Hopefully it won't be too distracting for you. So if you haven't already, fill out your table of contents. Page 107 and 108 is going to be where we tape in our notes on rational and irrational. The note sheet that you're getting today will get folded just a little bit, and that way you can tape it into your book. And the second sheet that we'll fill out together will also go in there. So you should have those things ready to go. Later in the week, we'll do this lesson on simplifying and solving with square roots, and that'll get taped on page 109 and 110. So look forward to another video to work with square roots later in the week. For today, your foldable note sheet, it would be helpful to fill this in that these are examples of natural numbers, so that way when you open your foldable, you'll actually have the name of the types of numbers that you need to know. Natural numbers are also called counting numbers. When you're little, you'll learn how to count items, so counting numbers start with 1, 2, 3, 4, and they go up forever and ever. Whole numbers include 0, so it's all the counting numbers, but then we have this idea of 0 that kids also learn when they're little. Integers you learned about in probably 5th and 6th grade. You worked on them again in 7th grade. You learned that they are not fractions or decimals. You learned that they include the whole numbers 0, 1, 2, 3, 4 and the counting numbers, but they also include negative numbers. So negative whole numbers, 0, and positive whole numbers. Here's the new vocabulary that we really need to know now that we're working on this last unit in 8th grade. There's types of real numbers that can be divided into two categories. We can call certain numbers rational, and those are the numbers that can be written as a fraction. So I always tell students rational, fractional. It kind of rhymes, and it's easier to remember if you can kind of hear those words rhyme a little bit. So even though some of the examples don't look like fractions, let me show you how you can remember. 3/4, the fraction, is equal to the decimal 0.75. So if somebody gives you the decimal 0.75, you know that it's equal to the fraction 3/4. Again, fractional means it's rational. Negative numbers can also be rational, and that's because we can divide by 1, make this look like a fraction, and it's still a fraction. So that's why if it's fractional, it's rational. We can take the number 6, we can put a 1 underneath it, and we have a fraction. So again, fraction, rational. 0.3 repeating. You'll see the repeater bar on top. If you were to use your calculator and you wanted to change a decimal to a fraction, you would have to hit 2 buttons. The first button is your blue second function key, and your second button is PRB. I believe it's right next door to the second function, maybe down a row. And that has a little F arrow D up top, and that means you can change any fraction to a decimal, any decimal to a fraction. So if you put 0.3 repeating across your screen and you hit second PRB, you're going to get the fractional value, 1/3. Again, fractional means it's rational. We have another number that we started to work with, and we're going to work with some more later this week, and that is something that is a square root. Certain numbers have perfect values. When you find the square root of 16, 4 times 4 gives us 16. So that means that 4 is the square root of 16. 4 is also a number that we can make look like a fraction. So that's why the square root of 16 fits in this category. But down here you'll see that I've got another category called irrational numbers. The little prefix in the beginning of that word, ir, changes the definition of the word rational. It reverses it, okay? We need to know that irrational numbers cannot be written as fractions. This is when you'll get a non-repeating, non-terminating decimal value. For example, pi. You should have learned about pi last year. The approximate value of pi, if you punch it into your calculator, you get approximately 3.14, but that value keeps going, all right? It's a non-terminating decimal with non-repeating decimal digits. If you try to hit second PRB, it will not turn it into a fraction for you. That's why we call this an irrational number. The square root of 5 also gives you an irrational value because there is no value that exactly multiplies it by itself. This comes out to be approximately 2.23, and then there's a 606, and then there's a 79 and a 78. So you can see again, it's non-repeating, it's non-terminating, and it has an approximate value that we can't change into a decimal, again, or into a fraction. So if you can't make it a fraction, it's irrational. If you can make it look like a fraction, it's rational. So fractional, rational is how you remember the new vocabulary. So the other note sheet that you're going to work on reminds us what rational looks like. It reminds us what irrational looks like. It gives us a couple more examples. 1.5 is rational because you can write it as the fraction 3/2. 7 is rational because you can write it as the fraction 7/1. 0.3 repeating is rational because we can change it into the fraction 1/3. These examples over here are not. Pi is irrational because you cannot write it as a fraction, just like the square root of 2 cannot be written as a fraction. So your job to complete this practice activity is to find out if the given examples are rational or irrational. You're going to circle R for rational and I for irrational, and then you want to plot the values on the number line. So we'll do a few together to start. 2 squared does give us the value of 4. 4 is a whole number that we can put a 1 under it to make it look fractional. So again, fractional means rational. And then on the number line, you can plot the value that was given to us, 2 squared, which has the same value of 4. 2/5, if you divide it out or change it to a decimal, comes out to be 0.4. Now, it was given to us in fractional form, so remember, fractional means rational. 2/5 is going to be approximately here on our number line, partway between 0 and 1. -1.5, again, it's already fractional, so we know it's rational. We know it's also going to be located here. -1.5 is between -1 and -2. The last example, 1.675. If you remember learning about decimal place value, this is tenths, hundredths, thousandths. We can write this immediately as a fraction just because we know our place value. So this would turn into 1 and 765 over 1,000. Again, fractional means rational. And again, we want to just make sure we place this on our number line where we believe 1.765 should be. Be careful with the next couple examples. You want to look and see what value they give you. You want to see if you can change them into a fraction. If they're fractional, remember, it means rational. If they're not, you're going to circle I for irrational. So pause your video, try those examples, and then play the video to check your answers. Okay, so hopefully when you work through these examples, you were able to convert -4.5 to -4.5, which again is a rational value, and hopefully you plotted it down here on your number line. 5.72 will have to be typed into the calculator so that the 7 and the 2 and the 7 and the 2 repeat over and over and over again across your screen, and then you can change it to a fraction. So remember, second PRB changes it and it gives us 5 and then 8 over 11. So as soon as you see it's fractional, you choose rational, and then you can place it on your number line. -pi, remember, has the value of approximately 3.14, so this is just -3.14. And again, pi is irrational, so -pi is going to be located about down here. Square root of 49, remember, 7 times 7. You need to know what number times itself gives you 49. This is a rational value because any whole number can be placed with a 1 underneath it. So let's write this as the square root of 49 so it matches the problem that we had. Negative square root of 6. The square root of 6, remember, is about 2.45. So because it's negative and the decimal value continues forever and ever, it's going to be irrational. So negative square root of 6 is going to fit about here. 2pi would be 2 times the value of pi. That's approximately 6.28, but it will not give us an exact value because the decimal continues forever and ever, so it's irrational. 6.28 is about here. And then negative 0.348, this again, we can use place value. Tenths, hundredths, thousandths. And 348, again, it's fractional, so it's rational. So we would plot that right about here on our number line. So if you have your notes complete, you will go ahead and tape them in. And this is what it should look like when you have this folded sheet with the definitions on the left and your completed note sheet on the right.